All right, so in this video, we're going to be looking at the solution to some radical equations, a radical involving radical square roots or other kinds of rational exponents. So in this particular problem, the main strategy that we have for getting rid of radicals is that we try to put the radical on one side by itself so that when we raise the radical to square it in order to get rid of it, that we're not getting cross terms and foiling and things like that. Now, that's not always possible. If we have two radicals in the equation, sometimes we have to do the squaring and solving and squaring again twice. But in this particular problem, we have a single radical. It is on the the right side by itself. And we're simply going to begin by squaring both sides of our equation. Now, we do have to be careful when we do the squaring that we FOIL the left side of the equation, that we don't try to quote unquote distribute the square because it'll be wrong. The other thing that we have to keep in mind is that because we've squared the radical, we are sort of messing up our sign information. We are potentially going to introduce extraneous solutions. We might get more solutions out than we actually end up having. And so we will have to check our answers. Now, this is not the kind of thing that tends to happen with odd powered roots, but when you're dealing with even roots, this is going to be a regular thing. All right, so if you FOIL out the left side, we get 4x squared plus 4x plus 1, 3 minus 3x. And so we're going to move everything over to the other side of the equation. So 4x squared. If I move the 3x, I get plus 7x. And if I subtract the 3, I get minus 2 is going to be equal to 0. Now, depending on your factoring strategy, you could try using the quadratic formula at this point. That's fine. Or this actually does factor 4x and x, and the 2 has to multiply on the other side because I need a plus 8 and a minus 1 to get the plus 7. So 8 minus 1 is plus 7, but negative 1 and 2 gives me the negative 2. And so the first one gives me 4x minus 1 equals 0. 4x is equal to 1, and x equals 1/4. And the second one gives me x plus 2 equals 0, or x equals negative 2. Now, we do have to check both solutions. We can't just assume that one or the other is right or that they're both correct. We have to check them in the original equation, not after we've squared it, in the original equation. And so when we do that, 2 times 1/4 plus 1 is going to be equal to the square root of 3 minus 3 times 1/4. And on the left side of the equation, 2 times 1/4 plus 1 is going to be 3 divided by 2. And on the other side of the equation, 3 minus 3/4 is the square root of 9/4, which does reduce to 3/2. So this one checks out. Let's try the other one. 2 times negative 2 plus 1, question mark, square root of 3 minus 3 times negative 2 Well, on the left side, we're actually going to get -4 plus 1, which is -3. But on the other side, we're going to get 3 plus 6 under the square root, which is the square root of 9, which is +3. So again, the squaring process, we created a loss of sign information, and now we're saying -3 is equal to 3, and that's not true. So -2 here is going to have to be excluded as a solution because this does not work. Now, let's look at another example that is also a little bit tricky. It's 5 minus 4 minus 2x to the 2/3 power equal to 1. Now, this initially is a cube root, but that square in the numerator of our power is going to make this a little bit more complicated than just a cube root by itself. Anytime you have an even number in an exponent, you're going to have to deal with either losing sign information or having two solutions, plus and minus values. So that's just something to kind of keep in mind when you're doing this problem. If you had like a 5/3 power, it would act more or less like a 1/3 power. As long as they're all odd, signs go through the odd roots at odd powers without any difficulty. It's the even ones that make the signs all weird. So first things first, we're going to move the 5 to the other side by subtracting, and that's going to give us -4 minus 2x to the 2/3 equals to 1 minus 5 is -4. Next thing is get rid of the negative sign out front. Now, it's very tempting to just kind of barrel forward and say, okay, I'm going to raise everything to the 3/2 power. And so I've got 4 minus 2x is equal to 4 to the 3/2. And it's not entirely wrong to do that, but where you'll get into trouble is that 2 again. So really what's happening is you're taking the 4 minus 2x to the 2/3 power, and you're going to cube both sides. That's what the cube root, or cubing both sides, that's the numerator in this previous step right over here, 3/2. So if I cube that's going to cancel the 1/3 power. That's going to give me 4 minus 2x squared is equal to 64. But see, now when I take the square root to cancel the square, to get that 2 in the denominator over here, when I take the square root, I need to get 2 answers. And that's where the trick happens. And so if you do this, again, that's fine. You will still get 8. The square root of 4 is 2, the cube root of 2 is 8. But because the 2 is in the denominator, you need to keep in mind that it is plus and minus 8, not just plus 8. And so if we then continue solving, I'm going to end up with -2x is equal to, we're going to have 2 answers. So 8 minus 4 is going to be 4, and -2x. -8 minus 4 is going to be negative 12. And so we're going to end up with x is equal to negative 2 and x is equal to 6. And if you go back and you check both of these answers in the original problem, you will find that in this case, they actually both work. So 4 minus 2 times negative 2 to the 2/3 power equals question mark. Well, let's see what happens. So we've got 5 minus. So this is negative 2 and negative 2 is 4. So 4 plus 4 is 8 to the 2/3. And 8 to the 2/3 is actually 4. 5 minus 4 is equal to 1. So you're good. And then when you do this with the other one, 5 minus 4 minus 2 times 6 to the 2/3, you're going to end up with, so 4 minus 12 is going to be negative 8 to the 2/3. Now the cube root of negative 8 is negative 2, but then you're going to square it to make it 4. So it's still going to be 5 minus 4, which is 1. And so both solutions work. And another strategy for verifying your solutions is to graph them. So let's grab graphs for both of our problems and see what the graph looks like. Now, if we go back to our previous problem, we can see that our intersection of our two functions, I plotted 2x plus 1 equals y for the left side, and the square root of 3 minus 3x equals y from the right side. And we can see the intersection is at 1/4. The other intersection actually comes from essentially the bottom half of this sideways parabola, which we don't have because then it's not a function. And that's where that other solution, you can see just barely off the screen here, that's where that other intersection would have come from. But there is no intersection for just the positive square root. There is with the negative square root, but not the positive square root. So this is our only solution. And if we look at the graph of the second case, again, this is the 5 minus 4 minus 2x to the 2/3 power. And then this is y equals 1 on the red line. And we can see that where they cross each other, there's two places where they cross. There's the negative 2 value, and there is this value for 6. So again, both of these confirm. In the first case, we had only one solution, and we got an extraneous one out of it. And in this case, you have to account for that plus and minus because you do get two solutions, not just the one.